Hi, my name is Not Purdue Pete, and welcome to my YouTube channel, Not Purdue University. Today, I'm going to be talking about one of the most important things in Purdue, and no, it's not about how we embarrass IU every season. It's about trains, or to be specific, about the steam engine. Now, you may know some famous trains like Thomas the Tank Engine, or the one from Harry Potter, or my favorite one, the Boilermaker. First, we're going to learn a little bit about the history of the steam engine. The first machine that we will recognize as steam engines today were developed to pump water out of mines. The first steam pump developed for this purpose was invented by Thomas Savery in 1698 and allowed mines to be dug deeper and become more profitable. Later in the 18th century, the technology was improved and adopted for other purposes. This began with Thomas Newcomen's design in 1712. The most revolutionary advancement was made by James Watt in 1765. This is the first design that strayed from the simple pumping motion that limited the use case of previous designs. From this design, many small improvements were made over time, driving the technological advancement of the Industrial Revolution. Now we're going to talk about the components of the steam engine. First, you have the firebox where the fuel is burned to create heat. That heat is used in the boiler where a series of pressure vessels containing water are boiled to produce steam. The steam dome contains all the converted steam released from the boiler. Then the steam travels to the pistons and cylinders that convert high pressure and temperature steam to low pressure and temperature steam. The difference in that energy is used to do work. For steam locomotives, rods use mechanical energy to do work, such as rotating the wheels to travel. Finally, the used steam is released to the smoke box where through a series of pipes it exits from the stack. The harder the locomotive works, the more steam is released. The place where the train crew operates their engine by controlling the fire in the firebox is called the cab. Now let's take an in-depth look as to how a steam engine creates steam. For this animation below, to convert lateral motion of the piston to rotational motion, pressure needs to be applied alternatively to both sides of the piston. For this to happen, a mechanism needs to allow the lower pressure steam to escape the piston cylinder while allowing high pressure heated water vapor to enter the other side of the cylinder and drive the piston. The mechanism that allows this to happen is called the valve and is the moving blue arm in the top right of the animation. Steam from the boiler enters the steam chest and is admitted to the front end of the cylinder by a valve. This high pressure steam pushes the piston backwards, which makes the wheel turn halfway. At the end of the piston stroke, the valve shifts again and allows the remaining steam pressure to escape through the exhaust port underneath the valve slide. This quick pressure escape gives the engine the iconic sound. At the same time, the valve is also admitting high pressure steam back to the cylinder, making the piston go forward and completing the wheel turn. At the end of the second stroke, steam is released from the rear portion of the cylinder and another is made. Because of its role in enabling the Industrial Revolution, the steam engine is perhaps the most important invention in history. Without the steam engine, modern life would be drastically different. The next time you see the Boilermaker drive by campus or on Dorset, you will know a little bit more about the engine that has powered trains for hundreds of years. Thank you for watching. This has been Not Purdue Pete.